Hello, today we have count unreachable pairs of a node. Let me share my screen. Here we go. So you're given an integer n, which is undirected graph with n nodes, numbered from 0 to n minus 1. Okay. You're given to the array of edges, the nodes that exist in undirected edge. There exists an undirected edge nodes A and B. Okay, the connection node. Return the number of pairs nodes that are unreachable from each other. So it's 0 because everything is reachable. Here is 3 multiplied by 4, and which is 12, and then also 2. Why it's 14? So this is unreachable, this unreachable, this unreachable, this unreachable, this unreachable. It will be and this unreachable. So amount of unreachable connection will be, wait a second. So it will be 3 multiplied by 4, right? We have plus n cannot reach 5 or 0 or 2 or 1, so it's another 3 multiplied by 4, right? 3 multiplied by 4 plus 3 multiplied by 2. Oh no, no, plus 2 because 1, 2, and then also 1, 2 plus 2 plus 2, which is 14. Okay, now I understand this. Okay, so the possible solutions are what we can obviously what we can do. We can count existing connections, and then we know that if we have n nodes, so total amount of connections will be it's a formula. I think it's not permutation formula. N multiplied by so in this case n multiplied by n minus 1 and divided by 2. So this is the total amount of connection, right? Let's call it total amount tag. Then total existing connection will be like some number, right? We can calculate it. Total existing connection, and our result will be tag minus tag. Right, this, right? So there are two ways to count these two values. So first way is DFS. From every connection, I'll go and count visit, like have a in this case we will have array of visited, and I'll do DFS from every node and count connection and count connection and make sure they are not in visited. and as a result, so let's say calculate total existing connection. And another way is to use union find, and so visitor will be array, and DFS will make sure they're visited, and result. Okay, so union find. So in this case, I will go from every node, create parents array, and find parent from every node, and if parent the same, and nodes are connected. So in this case, connection is found. About complexity, I think both of them square complexity, time complexity for both of them will be O n square, and space complexity will be O n for both of them. We have array of, here is we're gonna have array of visited, and here we're gonna have array of parents. So I don't know. I really want to try union find. I believe will be more chances to do DFS. So let's go with union find first. And for that, I'll create class union find. And in this class, we have a method in a name. So it will be union method, right? Which we have two pointers, like two nodes, X and Y. And we're gonna have also another method, union find, because all methods in the name find, and we have constructor. Constructor will have init, and it will accept a node amount of nodes we're gonna receive, and right away we're gonna create parent. So we're gonna self parent array, which will be amount of nodes in our graph, and then we need to create parent array, which is, oh wait, this is, oh, we have to create rank array, right? Parent array will be different because, no, okay, yeah, let's create parent array with, it will be different, it will be list. We are not initializing with anything parent array, it will be list of amount of n pre-initialized, and for union, when we'll be calling, we will have to, let's implement first, it's easier. So find will return value, it will accept node and return it parent. So, and it will be recursive call for this class. So if stop condition for recursion, it will be if parent x not equal, until parent x not equal x, until we reached the edge node. or like yeah, until node not equal itself, we will go and see if parent node we call self find on self parent x. If we return self parent x. Yeah, so in this case we will found parent of this node. Parent will be node with most connection. If connections are equal, like example 2, I don't know how it will work. If amount of connection like here, this has 2 connections, this has 2 connections, this has 2 connections, everything is connected. Yeah, I don't know if it will work. Okay, let's go ahead and implement this and see. Yeah, so union is a little more complex. So for that, we have to find parents for both x and y. So we call x parent, y parent equal self find. Right, we find parents, and then if parents are the same, then we just return. Otherwise, we have to, okay. We have to assign, now we have to assign which parent is of what. For example, if we have a, okay, so this is, yeah, we have to implement ranking here as well. Ranking is part of union find, and we have to do array of n, and in this case, if self ranking of x more than self ranking of y, so this is like amount of nodes expand. So we have a different, oh, we found node with different parents, right? Or parent nodes are different, so we, it's not like this, it's like this. So if nodes are the same, we just return. So we found, and okay. So here we have to implement ranking procedure to decide which. Okay. Yeah, so we have, when we will be, so let's get back to how it will be used. So for union find, we're gonna have, we create union find class, right? And go from this way, maybe it will be easier. We pass n, and then for e and or x and y in ages. What we're gonna do, we're gonna just call union method of this union find x and y. Right? In this case, we are declaring that these two nodes are connected. And for that, we will have to find, so if these two nodes are connected, we can count this connection, right? So for this, we just add self connection. Okay. So in this case, we will be adding a connection between two nodes, or okay, self connection will be so this is how many node connection array of nodes connected to node n. So if we have array from 0 to n, right, to n minus 1, and in this case connection x here gonna have n connections to other nodes. So yeah, I would better call it like rank is fine, I mean, but in it's in physically it's showing how many nodes connected to current node, right? So this is why when we count in connection, when we declare in connection for x and y, we can add whatever we have in a ranking. So it's like self-ranking x multiplied by self-ranking y, because we found connection between those nodes, right? Oh, we declare in connection. Connection exists for sure, because here we are like, it's not DFS. We are known that this connection exists, and we declare in a union. And this is why we're multiplying whatever connection these nodes have between itself, right? So like here we have 4 nodes for connection between of them. This have 2, this have 2, this have 2, and this have 2. So every node have 2 connections for 8. Yeah. Yes, it should work. So, and then For union, we have to also define uh, which is parent of which. So if X, ranking X parent more than ranking Y parent means that Y will be uh, Y will be parent, X will be parent of Y, right? Else we have vice versa. Um, right? And we have to add ranking for this, right? Because now whatever this become like main node, so ranking will be um, like this. So we are saying it's this node is has bigger ranking and it will be yeah, because it will be parent. So okay. Okay, and as a result, uh, we also have a connection, right? So then from union, we will have an amount of connection. Our total connection will be like as I specified here. Return I know, but just in case. Total amount of connection. Oh, okay, let's declare it. Let's declare tag total amount connection equal. Yep. And we return total amount connection minus total existing connection, which is union find tag. Okay, very good. So we created union find, run through it. Let's quickly find out union find connections list. Find parent. We add connection, whatever nodes have. No, whatever parents node have. Why is that parents? I don't know. Okay, I think it's parents. So if we declare, for example, if we because we are totaling, but yeah, I don't know. Okay, let's try to submit it. Okay, tac, 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 tac. This is amount of connection. Okay, submit. Oh, this is DFS. Union find. This is different calculation. Oh, I like it better. Also union find. Oh, this is counting. This DFS, stack for DFS. DFS is gone. Okay, that's it for today. Thank you.